Alright, hey guys, today I am going to go to my son's doctor's appointment, and so we are down in Charlotte, and you guys are going to be doing a virtual lab today. I've got instructions for you on Google Classroom as well as in this video, so I want to go through and show you kind of what we're doing. So first things first, there's no excuse for this not to work. Google Drive has been down, so you're going to do this on paper. Also, the computer might tell you that it's not going to work on your Chromebook, but there should be an option to go ahead and run the program anyway, and I want you to do that. It will work on your Chromebooks. If you click the link down here in the assignment, it's taking you to SAS Curriculum Pathways, and when you get there, it's going to take you to this page, and the page is going to show you the virtual lab for linear motion, and we're not logged in. The way to get into this is to log in. So we go to view this resource, and we're gonna log in. So when you click login, it's gonna pop up here, and you guys already have a password or a username. It's a school license, and so you're gonna type in for username Alexander Central, and there's no password, and you just go and log in. And it should take you in to the main site, and it will let you then launch the app. And so you're going to launch the resource right here where it says launch resource. And so this lab is going to open up, and you can take some time to watch the video. There's a little video you can play through, and once you're done, it tells you what we're going to do. You're going to be looking at position and velocity of moving objects over time as they undergo accelerations. We're going to be looking at position versus time, velocity versus time, and acceleration versus time graphs. And so you're going to be looking at the slopes of those graphs in this activity. So you can click start, and you can kind of see how this is going to play out. The program's going to load up here, and there's a few things. You guys are not going to be doing any of the data stuff on the journal side here, because I've gotten paper copies for you. So those paper copies are what you're going to do. It's just easier for you to write it down on paper, and that way you don't have to worry about your screen or anything or losing the data. So you're going to do this on your paper, so you can close this out. And so basically the directions are here. They're also in the journal that I'm going to give you on paper. But there are different things to do, and so if you look, this first section, we're looking at what happens to the position, velocity, and acceleration of the runner over time as she undergoes zero acceleration. So it says what's going on. And so for this trial, Inga, our runner, will not be accelerating. Move the sliders to match the following values. So it gives you the instructions. Our position is going to be 1 meter. And so we move our slider till it says 1 meter. And our velocity is going to be 2 meters per second. So there's our 2 meters per second. And our acceleration is 0 meters per second. So right now it says she's slowing down. We want to move this to 0. And so there it is. So we've got all of these. We're going. And so we're going to click go and run the simulation. And there she goes. And we're graphing the motion of Inga as she runs. And she's at the finish line. And we've got 3 graphs. We've got a position versus time graph, a velocity versus time graph, and an acceleration versus time graph. And we see the new position, the velocity, and the acceleration down here in the bottom of our data. And so you can answer these questions that we have down here on this side. And then we're going to do another thing. We're going to match these graphs, and obviously for zero acceleration we've got this one, and then velocity versus time is this one, and then acceleration versus time is this one. And so we can go through and we can do all of this, and then we're going to look at positive acceleration. So you're going to change her positive acceleration into 0.10 or 0.20, maybe whatever the directions tell you. Now the paper you're going to have looks like this, and it's got all the directions. It tells you for this trial, Inga, our runner, will not be accelerating. It's everything that's on there It just gives you a space to fill this out. Alright, it gives you a space to fill out every answer, and I want you to do that. You don't have to color in these radio buttons, you could just circle the graphs or anything like that. But that's what you're going to do as you're going through. And so this actually shows you step by step what you have to do well in this lab. So you're going to get through the 3 trials for positive and negative and 0 acceleration. And then it's going to move on to tab 2. And when you move on to tab 2, it's match the graphs. And so you can go through the directions, you'll set things up, and you're going to go and try to figure out which one you're going to do. So trial 1 is giving you this. And so we're going to try to match our tabs to make this graph. And if you remember, that was giving us one graph there. And so you're going to then answer the questions and follow through with the directions here. All right, in the simulation, the pull down menu, select a trial, enter the input values for Inga's initial position, initial velocity, and acceleration that you think will match to the yellow graphs. And so we already did this one. We knew that this was an initial position of 1, and it was an initial velocity of 2, and her initial acceleration was 0. And so if we go, we see that, hey, indeed, that matched her graphs. So we matched the graphs on that one. And so what we can do is we can go through and we can figure it out and then answer the questions as we go through and do the simulations. The last part is an analysis part, and that's a separate document that I've given you. And so in this analysis, you can actually answer those questions just based on what you've done. And so you've got 2 graphs, and you've got your analysis questions. You've got another table of graphs to look at, answer about this question. And so you can go through, and then there's a focus question at the end, where you can write a little paper there. So hopefully this works out, and you guys have no questions. If you do, the sub should be able to help you. If not, give me a Hangouts message, and I will try to get back to you. I hope you guys have a good day, and please be nice. I don't want to get bad reviews back from you. Thanks very much. Bye, guys.